So now that we understand that the universe itself is expanding, let's look at some of those consequences. But first, a question. Which color of light has the longest wavelength? A, blue, B, green, C, yellow, D, orange, or E, red? Go ahead and think about it, and then we'll discuss in just a little bit. So the correct answer is E. Red has the longest wavelength. So why is this important? Okay, so previously, when talking about the redshift we see for galaxies, we talked about it as though it were a Doppler shift, that because the galaxy is moving away from us, its light has been redshifted. And to be fair, this is actually how people first interpreted that redshift, including Hubble with Hubble's law. However, this redshift is not caused by the galaxies moving away. Instead, it is actually caused by the expansion of space itself. So what happens is as light is traveling through space, space itself expands, and as it expands, it stretches that wavelength of light. Okay, so this reddening of light, because of the expansion of space, this is known as cosmological redshift. Okay, so some misconceptions that I've seen regarding the expansion of space. Okay, so first has to deal with the motion of galaxies. So it is I have heard it presented that the galaxies are simply moving away from each other. Okay, that space itself is actually static, and the galaxies are moving away from each other on space. That is not what is happening. Okay, instead, what is happening is that space itself is expanding, and as it expands, it is drawing galaxies away from each other. Now, we should be a little careful. It is technically galaxy clusters that are being drawn away from each other. Something else that I've seen is that because space is expanding, so must everything in space. Okay, now this is also not true. For example, the Earth. The Earth is held together by gravity. Okay, the gravity of the Earth is actually stronger than the expansion of space. So space is actually expanding around us all the time, but there are other forces holding things together. So the Earth today is still the same size as it was 1 billion years ago. Atoms today are still the same size. Okay, it's only when we get to a very large scale that we see things being drawn away from each other. Specifically, galaxy clusters are still held together by gravity, but when we get to the scale of a supercluster, the clusters within the supercluster are being drawn away from each other. Now, one problem that we often have when dealing in cosmology and astronomy generally is that it sounds like we're saying two contradictory things at the same time. For example, it has been stated that the universe is infinite in size, which would mean it has no edge. And yet, occasionally, we hear news stories of astronomers find galaxies at the edge of the universe. And if it has an edge, then it can't be infinite. So how is it, what's going on? Okay, so what's happening is people aren't using terms very clearly. Okay, so we actually believe that the universe itself is infinitely large in space. However, we believe that there's an edge to what we can actually see. Okay, so specifically what's going on is we can only see out into space for as long as light has been able to travel. Okay, so in other words, we have this region around us where we can actually see things. This is what we refer to as the observable universe. Okay, so in this image, the dashed circle, everything within that dashed circle is our observable universe. Okay, the light from anything in this circle has had time to actually reach us. So in other words, we can actually see these things. Okay, so this galaxy we can see, this galaxy we can see, okay, this one we can see, and this one we can just barely see right now. It is at the edge of our observable universe. Okay, this galaxy we can't see yet. Okay, the light from this galaxy has not yet reached us. Okay, so there's still stuff beyond what we see, so the universe is infinite, but there's an edge to what we're able to see. There's an edge of the observable universe. Okay, so the universe itself, we again believe, is infinitely large, But the observable universe has a radius of about 13.8 billion light years in radius. Now, according to the Big Bang, which we'll talk about in a little bit, the universe is not infinitely old, and also things are in constant motion. So because of this, this is what gives us that edge. Okay, now this means that there are things that are beyond that we do not see, the light has not yet reached us, and we also have to deal with cosmological redshift caused by the expansion of space. So what this means is even some of these galaxies that are within our observable universe, their light will have been redshifted enough they're no longer in the visible spectrum.